Benefits of background workers. So start off, very quick reminder of how web servers work. You have a client, you send a request to the server, and hopefully the server replies with a response nice and quickly. Some of the time, the server takes a long time to respond to the request, and that can cause issues. So the first time I realized I needed to look into using background workers, I'd written some code that generated a report for the sales department, wrote the code, made sure it worked, deployed it, put it live, tested it work in production as well, and sent an email to the sales team saying, this report you asked for is available, please use it. Got an email back about 10 minutes later saying, A, the report doesn't download, B, the server's entirely dead. And I thought, that's a good trick. So I logged into the server to see what's going on, and yep, the server was just completely dead. Wasn't responding to any requests. It was just sitting there, apparently doing nothing. And then a few minutes later, it just started working again. It was like, great, it's fixed itself. I have no idea what that was. So this time, instead of sending an email to the sales team to please try using the report generator, I went over to the sales team and said, I'm going to sit with you and watch you use this report and make sure it works. And what happened was the salesperson went, look, I click on the report, I'm clicking it, I'm clicking it, I'm clicking it, I'm clicking it, I'm clicking it. And because the report took more than an instant to generate, in fact it took about 20 seconds to run, each click he did was sending a request to the server. So it was going, yep, I will do that request as soon as I can, but I'm actually quite busy doing all these other requests that you've sent so far. And of course, the browser, once you click again after doing the first click, it's just going to throw any response away. So he was just sat there, clicking, 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 clicking. So even if you don't have a sales team that does that, and even if you do things like use Ajax or jQuery to like hide the link after somebody clicks download so they can't do more than one request at a time, it's still really easy to accidentally have a denial of service attack on your server by having some slow code. I had a quick look. Drupal recommend using 128 meg of RAM as how much memory each request needs, and they actually say you probably want to have a bit more than that, more like 256 megabytes of RAM. So on a server that's got 4 gig of RAM, you can only serve 32 requests at once in Drupal before the server's just going to lock up and isn't able to process any more requests. So you want to take any big any requests that take a long time to respond. Don't serve them directly through from the web server, but shift them off to a background worker. I don't know if this one's going to work too well. Let's find out. First of 2 live demos. So the second thing is user experience. This is the second reason why I'd want to use background worker. I've got 2 forms with some programmer styling applied to them. In a moment, I'm going to ask you a question. Do you think form 1 was quicker to process or form 2 is quicker to process? So form 1, here we go. Processing, 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 complete. Okay, form 2, sending data, validating data, querying database, processing results, reticulating splines, complete. Who thinks form 1 was quicker? Form 2 quicker? It's not they're exactly the same speed. It's a trick question. When users get feedback about what the server's doing, for various psychological reasons, they're much happier. It gives them a feeling of confidence. They can see something's happening, so they don't get bored, and so they don't get upset at the server taking too long. And this is something you can do quite easily using background workers. And the third reason is security. So, as many of you probably already know, I'm the maintainer of the Imagic extension. I accidentally forgot the numbers can be less than 0 in one of the releases, and it turns out if you forget to check that the number's not less than 0, instead of reading the array of memory that you want to read, you read something else that's not really defined, you're just reading garbage in. So that's my only mistake, or that's the only security fault in Imagic that's my fault. There's this concept in looking at how secure software is of an attack surface. ImageMagick, the library that the Imagick extension uses to do the image processing, is a huge library by itself. It also uses a huge set of libraries to do things like decoding pings and JPEGs and then encoding them. And then it also uses a whole load of what it calls delegates, which are command line tools to process some image formats. So as an example, if you process a PDF with ImageMagick or Imagick, it will actually invoke a tool called GhostScript to render PDFs to a rasterized image format. And because it's got such a huge attack surface that you can, different places you can like put silly things in, like here, this is one of the graphic formats it's ImageMagick supports, and somebody's put a URL in and then put a command at the end of it. Because that data wasn't validated, there's a bit of area that somebody can attack ImageMagick or the Imagick extension, and in this case by just uploading an MVG file that looks like that. So I've got one CVE, which I will fully my fault. The underlying ImageMagick library has 535, and there's certainly many more to be found. This group has a code of conduct, so I'll be careful of my next sentence. I think if you use the Imagick extension in a server that's facing the internet and people can upload arbitrary images to, I think you're a very, very silly person. There's just no way that it can be made to be secure. It's always going to have some security holes in it. You're much better off, instead of doing the image processing actually in the server, do the image processing in a background worker that can either be on a separate server or on the same server within a really locked down container. As an example of this, the bit of code that you use to process images doesn't need to know about your AWS API keys. You can just like run it somewhere where it doesn't have access to the API keys, and then even if somebody compromises that bit of code, if there's no way out to get at the actual secret data, there's very little damage they can do. So, drink of water because it's quite warm in here. So the idea is, instead of just having a client and server, we also have another container or process that we'll just call a worker that actually just does work in the background. So now, a request comes in. Instead of the server doing a whole load of work, it pushes the data off to the background worker and returns, this is an optional step but it's quite useful, return a job ID so that the client can query what's the status of that job. While the job's being worked on, as I said, the client can query the server and say, is that job ready? What's the status of it? And then once the actual work's done, the worker process can send the data back to the server, say the job's ready, and then the server can send it to the client where the client next asks for it. Demo time. So this is a demo that's going to generate an image for us. I need a nice adjective to describe PHP Southwest.
Brilliant.
Brilliant. That's a really long word, Andy. Can I just use brill? I'll give you an exclamation mark there as well. So I'm going to show you the code, go through a bit of the code, not all of it, in a moment. But what this is doing is we send a request to print out a picture with the word PHP Southwest brill. That's gone to the server. Because as you can see, it takes a long time to generate this image. We take the job ID that the server responds with, and we're just constantly polling, is it ready yet, is it ready yet? And the server is replying back with no. It's processing frame 13 out of 20. And even though it is quite boring, it's still better there. It's still better to see the progress going on rather than just being sat here twiddling our thumbs. Is it going to work? Yay! The cursor's lifted. More amazing programmer CSS. So, this is the point where I need to click somewhere else in the window so I get focus back on the mouse pointer. Yeah. So what do you need to do to implement background workers? I'm not going to go through all the code in depth just because that'd take too long and be a bit too tedious. I'm just going to point out the components you need and some important aspects of them. So you need a job or / message queue, some code to send and receive the jobs, something to keep the code running, and some code. You need some specialized code to stop the jobs. So message queues. Unless you're working with something like working in a field like a bank or dealing with money, you can pretty much use any message queue. The more specialized ones are for more advanced applications where you need to have better guarantees about reliability or routing of messages inside a large application. The only thing, I recommend pretty much any of these pieces of software will meet the need for a basic background worker. The only thing I'd like to say when choosing your message queue is make sure you choose one that allows you to query how many messages are on it. The Google PubSub queue does not actually support that out of the box. You are able to get the data if you go through the logging API, but I'd much rather just be able to call the API normally rather than having to go through a logging thing. Some people may have accused me of liking Redis a bit too much. I have no idea why people say this. It's one of those technologies, though, that it's quite simple. It only does a few amounts of things. Okay, sorry, there's a photo being taken. I want to send it round. Cool. Redis is normally used as a cache more than anything else. It's really, really fast. I use it for session caching, and it's also got Lua scripting library embedded in it, so you can do coding within the cache layer, which will be allows you to do really advanced stuff. As I said, I'm not going to talk about message reliability that much. I will say that Redis is probably not quite reliable enough if you have an application that absolutely can't tolerate any failed messages. But then if you have an application like that, to be honest, the technology that you use for the message queue is actually just a small part of the solution to that problem. You need to start thinking about what happens when you do deployments and the code changes. So like push a message onto the queue, do a deployment, and the message comes off the queue, and the code's expecting there to be a field in that job, and it doesn't exist there. It's a huge problem to solve, so I'm going to skip over it. So from the example we did, this is what an image job looks like for me. We were just passing in a piece of text for the string to use. Another little thing, I strongly recommend just writing out manually the to string and from string functions for when you're pushing it into the message queue and reading it back off. They're pretty much always going to be really simple bits of code, and it's much better to do it by hand than use PHP's internal serialization library for many reasons, including the main one: nobody should use PHP's internal serialization library. It really does not work that particularly well. So this is what the code looks like to actually send the jobs. So one of the things that Redis allows you to store data in a couple of different formats. You can either just store a single piece of data on a key, you can store sets, and you can also store lists. And list is the data structure that you want to use to implement a queue. Our push means that it's got a queue, and we're going to be pushing onto the right side of the queue. So any messages that arrive will appear on the right hand side. And then the next bit of code, this Redis BL pop, it will try and pop a message off the left side of the queue. And what that does is a basic first in, first out thing. So messages will be processed in the order that they arrive. The reason why I particularly like Redis for this is that you can set a timeout for the pop routine, and the code will just sit there waiting for a message to arrive, and it will just sit there very patiently, not using any CPU until there's a message available. I'll probably come back to that later when talking about other things to think about. Oh yeah, and this is another little thing I've used from actually using Redis, is I quite strongly recommend embedding all of your key generation in a particular class, and then using that class name as part of the key. What that does is when a system administrator wants to figure out why Redis has run out of memory, they can just do a dump of how much memory is being used by each of the keys, and then because it's a class name, you can just go straight to that class, and then if you're using an IDE, you can do find users, and it will just show you all the usages. It's one of those things that you don't think of until you're trying to figure out why all your memory's gone, and you go, I've got no way of debugging this, and you go, I will learn for next time. So the next piece that you need is something to keep the code running. PHP running in a web server has its own, when PHP is running in a web server, the web server will keep PHP running either through Apache, maintaining that, or PHPFPM has its own process worker. Because we're going to be running stuff effectively from the command line, we need to do that ourselves. Supervisor D is a fantastic tool to do that. It's a Python program that just runs other programs. And it's another thing that I'd recommend people have in their toolkit of technologies to use, because it just works. It's not. I was showing you the config just to show how easy it is. The things we need to set are which directory the program is going to run in, what the command is, a process name for logging purposes, and it allows you to set how many copies of the program you want to run, and whether you want the program to start automatically and restart automatically. That's pretty much it. It takes 20 minutes to set up a job working. A background worker running in Redis Supervisor. It also comes with this nice little interface that allows you to start and stop the jobs. This is more useful for local development rather than actually using in production, because when you in production you want to have like a single big button that turns off all of the background workers most of the time, rather than having to go through them all individually. And yeah, logging is there, but again, I recommend that more for debugging rather than anything else. So, one thing Supervisor doesn't do, at least out of the box, is it doesn't allow you to do dynamic scaling all that much. And these days, people are all about that scaling. I'm going to go slightly off topic here, just for a tiny bit. There's a couple of things I'm interested in, probably a bit more than the average programmer. In particular, I find it quite interesting learning about how people think. I also quite like graphs. And some of the time, those two things cross over. And in particular, there's a graph that I use that allows development teams to think a bit more clearly about how to choose a particular technology. A lot of the time when people are trying to figure out which technology to use, they try and make the argument of which technology is better than the other one. That's almost always the wrong thing to focus on. Instead, you want to focus a lot more on which one is going to deliver what you need in the shortest amount of time in development. And a lot of the time, when you're comparing two different technologies, there'll be a simpler technology and a more complicated technology. So an example of this would be something like having to choose between, say, WordPress and Slim or Symfony. So WordPress comes with a whole load of features out of the box, and if what you want on a project will fit within this first bit of line where WordPress can do what you want it to do straight away, you'll be able to get stuff done really quickly. At some point, you're trying to do stuff that's outside of WordPress's scope, and due to having to work inside WordPress's framework, the rate that you'll be able to do stuff in will slow down massively. And then the more capable tech, I'm pretty sure, so obviously you can build a blog out of WordPress, and you can build a blog out of Symfony. It's going to take you longer to get the same amount of features done building it through Symfony. But then Symfony can scale a lot more and be able to do a lot more stuff that WordPress might not be able to do. So rather than thinking about which technology is the right one to choose, it's much more important to figure out how many features you need, and will a simpler technology be able to do that. So we can see that if on this graph we actually only need features up to here, then in all of that region, WordPress or the simpler technology would be the right choice. If we know that we're above this line, we need to have a whole load of features delivered that are going to be beyond the scope of the simpler technology, and we're going to have to do them ourselves. Then you're probably better off choosing the more capable technology. And then there's a horrible region in the middle where you're probably just going to make the wrong choice no matter what. But if wrong topic for this talk, but you can actually sit down and do some maths and look at what the probabilities are of what's the chance that the simple text is going to be good enough versus the probability of that the more advanced text the right one, versus the cost of implementing first one and then the other, and do some maths to figure out the best choice rather than just figuring out which one people like better. But what if you just don't need to scale? So talking about background workers, I said that Supervisor D doesn't allow you to scale them out of the box. What if, instead of trying to scale your boxes, you just throw servers at it to begin with, and you provision more capacity than you can ever possibly need? So, as an example for sending emails, imagine that we want to, this is from DigitalOcean, if we wanted to get a box that was, all it was doing was sending emails, taking emails to be sent from a message queue, sending them through an email sending API. There's this box we can get, which will give us 4 GB of RAM, $20 a month. If you imagine that each worker for sending an email needs about 16 megabytes of RAM, and that would allow us to have 256 workers, 8 business hours during a day, 5 days a week, 4 weeks a month, 3,600 seconds in an hour, and then say it takes 4 seconds to send an email. That would give us the capacity to send 36 million emails a month for the cost of $20. And we avoid the whole complexity of setting up any scaling. We just provision far more capacity than... Does anybody in this room send more than 1 million emails a month? Nope. Oh, well, okay. Rob, you're an exception. But I think in general, even if you might one day, you either need the capacity straight away, or for the time being, go with the $20 a month option, skip the whole scaling stuff, and only address it when you actually need it. Sorry about that. Had to get that off my chest. So the next component you need is some code to run in a loop. This can be pretty simple if you are using Redis or anything else that will allow you to will allow your PHP script to just sit there waiting for a message to arrive. So because I use Redis most of the time, I don't need to put any sleeps or any other mechanisms in to slow the process down. That's provided by Redis out of the box. If you're not using something that will just wait for the messages, you need to think a bit more carefully about making sure that you're not going to be spinning your code as fast as possible. So for example, if instead of using Redis, we were querying a database for the email workers, and but each of them was going as fast as it could, is there a message to send, is there a message to send, is there a message to send, would be doing about 256 queries a second to the database, which would probably slow things down a tiny bit. If you need to get your data from somebody else's service, so like you're polling a data provider, and and again you provision 256 workers, and you're getting data every second from that data provider, they'd probably get a bit upset with you, asking for that many requests, and would probably ask you to tone your stuff down. Basically, it need to implement some sort of rate limiting if the message queue you're using, or the source of the messages you're using, won't do that for you. And again, final note is you definitely want to avoid spinning your own CPUs at 100%, because otherwise the planet's going to die. So one other thing people need to be aware of is there's this check signals for exit, which is probably new stuff or something you're not exposed to in a web environment. So you know when you press Control-C on a keyboard, that's called a signal. It's the interrupt signal. It basically tells your program to stop processing at your convenience. This is actually the standard way that most containers and Kubernetes systems work. Is the thing that's running your container will send signals into it, telling your programs it's time to shut down. So yeah, sig int is the equivalent of Control-C. Sig term is a graceful shutdown, and sig kill is a sig kill signal will be sent and the container violently terminated, which doesn't sound like a great thing for data integrity. So yeah, again, you've just got to think what your code's doing and make sure it's not going to take too long to shut down once the signal's received. So this can actually happen quite easily. Imagine you've got a background worker that's doing 2 HTTP requests to another service, and each of those has a timeout of 20 seconds. So it starts the first request, the sig term signal comes in, but then that HTTP request is still in flight, and it lasts just under the timeout you've set, so like 19 seconds. And then the worker starts doing the second request because it thinks it still needs to finish the job. That takes another 19 seconds. If you've got your Kubernetes cluster or whatever runs your container set to 30 seconds before it will just terminate the container violently, your jobs can be interrupted. So you need to think, well, this part of the job can take 20 seconds, this part of the job can take 20 seconds. We need to give all of the containers at least 40 seconds to shut down gracefully to avoid this problem. And that has a feed-on effect on how you do your deployments, because obviously containers need to be shut down before new ones can take over properly. And yeah, so this is the only code I recommend people actually copy. There's a couple of different ways of listening to signals in PHP. In particular, there used to be a tick handler where you could listen for ticks, and it's not recommended to use that anymore. This function is a self-contained. It will initialize itself the first time it runs, set up some handlers to listen for the signals, and then after that, the next time, subsequent time as it's run, it will just return true if it's time to exit, and false if it's not time for exit. So there's quite a few other small benefits that I couldn't fit into the main body of the talk. A lot of these benefits are just really nice to have, and they make running a system be a much more pleasant experience for both you as a developer and also for your users as well. So things like if you notice that your email provider is having an outage, you can stop attempting to send emails to them, and then by stopping the background worker that processes the emails, and then when their service is back, you can start that up again. And instead of having potentially lost emails, you'll have emails delivered a bit more reliably. And also you can restart failed jobs rather than code being difficult to restart. You can, if you see that a particular job's failed, you can just take that whole job, put it back onto the message queue, and it'll just get processed again. Probably want to make sure that you don't process any single message more than a set number of times, because processing the same thing infinitely is probably a bad idea. Performance tuning's a really nice little thing. So for stuff like sending emails, you don't need a powerful CPU. So the container or the process that you're running your email workers in can just use a very cheap, underpowered box. If you're doing stuff like image processing or generating huge reports that take huge amounts of, or need to have a huge amount of memory touched to generate the report, you probably want to provision a more powerful box. And you can allocate the workers. Email worker, work on the underpowered box. Stuff like that needs a lot of processing power, work on the high-powered box. And it's also, using background workers actually makes both your web server and your background jobs be a lot easier to process. So like, if normally there are requests that take a long time to process within your web server, you're not going to notice if there's some other requests that shouldn't take a long time to process but actually do. So stuff like database, stuff like queries, stuff like requests where there's queries that are being locked up in the database and it's taking 10 seconds to acquire a transaction lock in the database. You'll be able to like put slow request logging in PHP. If you've got things that are taking a long time anyway, that data will be lost in the noise. As I said, it's a really good idea to make sure that your background workers aren't spinning at CPU, so you can like accurately measure how much CPU they are using. Because most of the time, when there's no work, they'll be at 0, and then if you go to 100% when they're full, you're able to look at that separately from your web server. And the other thing is that if you find that you do have a job that needs a more powerful language than PHP to process, so like either Python or I think there's this language called R for data processing, which is when you've got enough data, PHP is not going to be the right choice. Because it's all separate from your web server anyway, you can have that particular background worker use different technology and it will work better. That's the talk. Any questions?
What's wrong with just using a normal database instead of Redis and then just...
It's not as cool for us to start with. It's perfectly fine if you're not going to have that many background workers running at once. So it'd be fine if you just having a few messages a minute, something like that. As soon as you get a bit more load than that, I would be hesitant to use it, just because the scaling drops off very, very quickly. Like even just having 8 workers, I'd be going, oh, we'll have to figure out how to make these both be able to query the database fast, but also not lock up the database while querying it. Whereas with Redis, you could go to 50,000 messages a second and it would just not even be breaking a sweat. That's the main reason. Any other questions?
That supervisor config, so can you fire off multiple workers and it looks like it's absolutely stable?
Yep, so the way I actually do it is I actually generate my config. I use Docker for pretty much everything, including in production, but that's a different story. I generate this config file when the containers run, so I'm able to set an environment variable outside of the container of how many workers I'd want. So when the container, say I choose 8 workers and I realize that that's nowhere near enough, I can change the config variable outside of the container in just a normal PHP file or wherever, restart the container, and it will generate a new version of this file with the appropriate number of processes. That's another reason why I don't think scaling is something you can skip, because if you can just use your own tool for generating and scaling, and just have a simple restart scaling it. That's again good enough for most people. Cool. Let's go to the pub.